graph in one. But it's not 7, it's 2. So here's the thing. A piecewise defined function is a graph that's in pieces. All right? But the domain of each piece is restricted because it still has to be a function. So all of these are still going to pass the vertical line test because they are still functions. You could make a piecewise function that doesn't. It won't be a function anymore. But all of ours will be functions still. So you can always check your answers at least enough to say, is this still a function? Does it pass the vertical line test? And if it doesn't, that means you've graphed something wrong. And so anytime you have a piecewise function, I couldn't really get my brackets to work out very nice. But they always have like brackets around them, and they just give you the function, and then usually there's a comma, and then it tells you, graph this function when x is less than or equal to -4, and then you're going to graph this function when x is greater than -4. And all this part is it's telling you where to break your graph up. There could be 3 pieces there, but I don't think we do any more than that. 3's the most we do right now. In Algebra 2, they do some crazy ones over there. I think most of ours are too. Maybe. The next one. On the next slide. So, when I taught this in Algebra 2, I always taught my students to break your graph up at this point, so that way you knew at -4 your graph was going to break up into 2 pieces. You don't have to show that line, but I think it helps, especially if you are unsure about doing this. So I'm just going to draw a dotted line, because remember a dotted line isn't really on the graph, just like to help me. I can erase it if I want later. In a book, and when you see a piecewise function graph, there's never going to be a dotted line there, but it just kind of helps you break it up. And what we want to do is we want to graph this function when it's less than or equal to -4, which would mean on this side of that line. So we're only going to have it over there. How do you graph x plus 1? 1's the y-intercept. So don't do this on a paper yet unless you have pencil that you can erase. But I would put a 1 there, and then what would I do? Slope is 1 over 1, so I go up 1 over 1, or I could go down 1, back 1, and it's just that line, right? But the problem is, I'm on the wrong part of the graph, right? I have to be over here. So you have options. One option is, could you just keep making dots until you get over here, and then go back and erase those? Yeah. Yep. Could you just not really make a dot, but in your mind, you could say, oh, it's at 1, and I could go down 1, back 1, and just keep going until I got over here, right? That would work too. Or, what someone else suggested one time, which I never thought of, I always just counted, and he said, why don't you just plug -4 in there and see where it starts? Oh, that's a genius idea. If I plug -4 in there, it's like an XY chart. If I plug -4 in there, do you agree that we get -3? All of those ways are acceptable ways to find your point. You could actually just graph it and keep making your slope until you get over there. Or you could just plug in where it starts and make your point there, and then do my slope. It's up 1 over 1, but I got to go this way, so I'm going to go down 1, back 1. And why did I make a solid dot here? Because it's included. That's supposed to be a straight line. Whatever it is. And all we've done is graph a linear line, but we've only graphed it on this part of the graph. It has to stop at -4. And then I'm going to graph the other part on the other side of the graph. And you need to make sure that you go all the way to this point, right? So this one, I usually graph the one that's where the y-axis is first because it makes me happier. Because I can say, oh, y equals mx plus b. I can graph a y-intercept of -3 and a slope of up 1 over 2. But don't just make it like this, right? It has to go greater than -4. So you have to go all the way to -4. So I'm going to go down 1 and back 2. And I'm going to make an open circle on that one because it's not included. And basically what I've done is I've graphed 2 equations on the same graph, but I've stopped it at -4. And it tells you where to stop every time. Like, you don't have to figure that out. Does this still pass the vertical line test? Yes, because this one is included, this one's not included, so it still only touches once there. And then, like, you don't need the dotted line there. I don't want you to think that's an asymptote, but you don't have to go back and erase it either. But just so you don't think that that's there. What if I asked you if this was a continuous function? What would you say? Not continuous, because remember, continuous means you wouldn't have to pick your pencil up, and we'd have to pick our pencil up to get there. Questions about that? People get overwhelmed, I think, because it looks a little scary, but if you just do it piece by piece, it's not so bad. Want to do another one that's not linear? Hooray! Let's do another one. After a 3-day weekend. What do I ask you? A question if I don't listen to your answer? I like for you to feel like you have a choice, even though you don't. So since this is precalculus and not algebra 2, in algebra 2 you only graph linear piecewise functions, but now that we know our 10 basic functions, I can throw these fun ones in. And I believe on your homework today there's a couple of these, and they say graph, and then say is it continuous, and they might even say like, how do you know, like, explain your answer, is it continuous? Well, it's continuous, you have to pick pencil up, or it's not continuous, there's a gap, or a hole, or you have to pick pencil up. So when you're graphing something other than a linear graph, you can always make an XY chart. You can make an XY chart in a linear graph too. XY charts always work. XY charts aren't always the best method, and so remembering those rules about transformations are a really nice thing. Do you remember what a number added or subtracted outside of a function does to the graph? It's up or down, right? And so if you remember that, you can be like, oh, I know what x squared looks like. It starts at 0, 0, and it goes up like this. Plus 3 means it's moved up 3. Or just pick a point. If you plug 0 in there, normally it's 0. But now if I plug 0 in there, it's up here at 3. With me on that? And knowing those basic shapes are a very nice thing, because normally on a parabola, unless there's something multiplied in front, right, when you plug 1 in, you get 1. When you plug negative 1 in, you get 1. Well, I just moved it up 3. So now when I go over 1, I should also just be able to go up 1. Did you guys do that in algebra 2 last year with Mr. McClure about how you just know the shape? But guess what? I could make an XY chart. I'm basically just plugging things in. If I plug in 0, I get 3. If I plug in 1, I get 4. And I'm going to, oh my gosh, what am I doing? I'm not graphing piecewise, am I? Which side should I be on? Right side. Erase this. Oh man. If I plug in 2, I get 4 plus 3, which is 7. Make enough that you can see a curve there. I don't know what it is. I just got so excited about making a parabola, I forgot that I was only making half of it. Everybody with me on that? Worked out really nice that the dividing part is at 0, so it's just going to be right here on the y-axis. Absolute value. What does the absolute value graph look like? V-shaped graph. Normally it starts right here at the center, and it's just a V shape. You know what that means? If there's a -2 inside there, it goes to the right. It's the opposite of what you think, right? And we can write these out if you want. A number inside always moves to the right or left, and I always say it's the opposite of what it should be, because minus actually goes to the right, which means if I plug 2 in there, I get 0, right? Can I put a dot here? No, because I'm supposed to be over here, right? But just saying right now, if I was going to graph this, it would move over, and then it's going to be that V shape, and you can kind of do the math there, like it's just moved over 2, that's the transformation. So just like the linear one, we can kind of graph it and then go back to what we need. Or we can just pick 0. If I plug 0 in this one, I get 2 as the absolute value. And that one should be an open circle. If I plug negative 1 in there, I get 3. And again, I know the shape is the V shape, so it really is just going to look like a line because the V part's way over here. a very big open circle I made on my graph. So we can graph these even if they're not linear. Okay, that's why knowing the shape is helpful. That's why knowing the transformations are helpful, because you don't have to always make XY charts. What about this one? Is it continuous? What's the only way a piecewise function is going to be continuous? What if this would have started right up here where that dot is, or that would have started right where that dot is? Like if one starts where the other one stops, like right at the same y value, then it could be continuous. So a lot of times they're not, but sometimes they could be. Let's go through the transformations really quick just to kind of write them out for you, and then we'll graph one that's not a piecewise function. I'm going to add my own little transformation page here. Every time you learned a new graph last year in Algebra 2, there'd be a little chart that would say transformations, and it would use H and K, and I think it used an A in front for like a stretch or shrink. Those are very useful because it's the same no matter what the graph is, whether it's a quadratic or a cubic or a square root or an absolute value. If you have the same idea going on, then you can figure out what's happening. So if you're going to move, let's just say if you have f of x plus k, that means a function plus a number on the outside. This means that it moves up k units. If you want a real example of that, would be like the one we just did, like x squared plus 4 would mean that that's an x squared, and then you move up 4 units. I don't know if we want to write this. We could say plus or minus, but I'll write it out. We have f of x minus k. That means it moves down k units. So like the absolute value of x minus 3 on the outside of it means that V shape is just moved down 3. Left and right, it's inside the function. So that would be like f of x minus h, right? So it's inside the function, means that it moves right h units. So an example of that would be like x minus 3 squared, right? So you see how the squared is not just with the x now, it's with the whole thing. That means that parabola has moved right 3 units. And so if you just change it, it's going to be left. So if you do f of x plus h, that means it moves left h units, kind of like the absolute value that we just did. So I should do it differently. How about the square root of x minus 6, or plus 6, sorry. Means that half of a parabola is now going to be moved left 6 units. So left, right, up, and down, very nice if you can recognize them, because if you know the basic shape and you know this, you just kind of move it over, so you don't have to make the XY chart. XY charts work, but you don't have to do it. The other one is the number in front, the stretch or shrink. Those you do, sometimes you still need to put your number. And I think we talk about this later in another chapter, but like if you have a times f of x, I'm just going to say stretch or shrink. Stretch or compress, I think that's what this one uses. If it's a number bigger than 1, like a 2 in front of it, that actually means it stretches. And then if it's like a fraction between 0 and 1, then it actually compresses it. I always say it, I don't really care that you memorize which is a stretch and which is a shrink and all those little rules that go with it. I just care that you know if there's a number multiplied, like 2x squared, then it's going to change your graph's shape. And so those are the ones that it might not be a bad idea to pick some points on. But there are 3, I think, on your homework today that I want you to graph. And the book says to graph with the graphing calculator, but I put in the homework I want you graphing it by hand, not with the graphing calculator. And hopefully this maybe will help a little bit, but if not, you can just make an XY chart. It always works. And I just picked this squared one doing? It's moving left 3, right? Back 3. And so instead of normally starting here, I'm just moving it back 3. So if you remember that and you know what the shape looks like, the idea is you don't have to make an XY chart. Because you know, normally when you start here, when you plug 1 in, you get 1. So guess what? If I just move it back 3, when I go over 1, I'm still going to get 1. And normally at 0, when you plug 2 in, what do you get? 4. So guess what? If I go over 2 from where I start, 1, 2, 3, 4, it's going to be the exact same shape. It's just like you slid it over. In geometry, you call them slides, dilations, whatever that word. If you don't know this, or you're like, I'm never going to remember that, guess what? Make an XY chart, pick some points. What I want to caution you about is make sure the shape is right. Like, let's say you just picked 0, and you got 9, and then you picked 1, and you got 16. If you know the shape is supposed to be a parabola and you just keep getting bigger numbers, that should tell you to go back and pick smaller numbers until you get that shape. And we do put arrows on the end of our graph to show that it goes on forever. It should be a smooth curve. I should be able to distinguish between your absolute value graph and your quadratic. And again, you get some more practice with domain and range. What is the domain of every quadratic function? All real numbers. Negative infinity to infinity. And we wrote those out in our notes when we wrote those 10 graphs. They're not always going to just be what we wrote out, because if we transform it, if we move it left, right, up, or down, then it could change. The normal parent graph, we said the range was 0 to infinity. Is the range of this graph also 0 to infinity? Yes, because I didn't move it up or down any. I just slid it over. If we would have moved it up or down, then the range changes. So the range of this is also 0 to infinity. So use those notes to help you, but also use the graphs to help you. Questions about that? Since we broke this up, normally I do 1, 3 all in one day, but we had the homework quiz and it just didn't happen. So you have, if you did the other homework, the matching or saying which graph goes to what, you don't have much left to do. So the red is what we have left to do. You should have the rest of that done. We didn't talk about it, but we'll talk about it all tomorrow. I would be happy if you just did this all on the same paper that you started it on, but you can do new paper if you want. But 29, 30, and 33, kind of ignore the directions of graph it with a grapher and graph those by hand. And then 45 and 50 are piecewise functions. So those are only 5 questions. They are graphing ones, 5 graphing questions. But you actually have a good amount of time. You should probably get those finished and finish the other part of it.